Gate CSE 2019. Which one of the following is not a valid identity? There are 4 Boolean expressions given. We need to identify which one among the 4 is invalid. To identify the invalid identity, let us start from option A. Option A claims that x XOR y equals xy plus x bar y bar, the whole bar. Let us consider the left hand side of the given expression. X XOR y means we know that xy bar plus x bar y, which indirectly says that when the inputs are different, for instance, x equals 1 and y equals 0, or x equals 0 and y equals 1, output is going to be high. So naturally, XOR gate produces output is high when the inputs are different. Coming to its complement XNOR gate, which says that when the inputs are same, output will be high, like either 0-0 combination or 1-1 combination is applied at the input, output is going to be high. We all know that XOR gate is the complement of XNOR gate. So here also, if you check with the right hand side of the given expression, xy and x bar y bar, which is nothing but XNOR operation, complementing the XNOR operation, we are getting XOR operation. So option A, obviously a valid one. Now let us check with option B. Option B says that x XOR y is equivalent to OR gate under the condition that when xy equals 0. What exactly it says? Xy equals 0 when x input is 1 and y input is 1, output must be 0. If this is the case, we can say that XOR operation and the OR operation between the two variables are equivalent. As we all know that the name XOR stands for exclusive OR. Again, this has come from a reason that if you compare OR operation and XOR operation, only for a specific combination 1-1, your OR gate produces logic 1 and XOR gate produces logic 0. So except this 1-1 combination, all other combination produces same results. So as per the given definition, only when x and y are equivalent to 1-1, if the device produces 0 output, then we can say that OR gate is equivalent to XOR gate. So option B is also a valid one. Now let us go for option C. Option C says that performing exclusive OR between x and y first, then perform XOR with z. The other way on the right hand side, perform XOR between y and z first, then perform x. So here it is something like associative law we apply for XOR gate. As we all know that doing the operation, the order of operation in a different way, it is going to produce the same results in case of exclusive OR gate. Either you do x XOR y first or y XOR z first. Even if you change the order, the result of two operations or computation going to be same. So option C also valid because it is associative law applied for the XOR gate. Now coming to the final option, option D, which says that performing OR between x and y, then perform XOR with z is equivalent to performing OR between y and z, then performing XOR with x. So here, what do they claim? Interchanging the operation, right? Interchanging the operator as well as the order of the operation, like y and z first, then x. If that in that way, if we do, then both are equivalent, it claims. Now let us verify by having a truth table, keeping the 3 variables as input, then perform left hand side x or y first. According to our operation between x and y, when any one of the inputs are high, output is going to be high. Perform OR operation first, then perform XOR with z. So performing XOR between x or y, then with z means when the inputs are different, output is going to be high. When the inputs are same, then output is going to be low. In that way, we complete this table. Coming to the right hand side, we perform OR between Y and Z here. So Y and Z means these two columns, Y and Z. We perform OR operation. Any one of the input is high, output is going to be high. Now we perform XOR with the X. Here it is. When inputs are same, output is going to be low. When the inputs are different, output is going to be high. In that way, if you fill for some of the combination, like when the input is 0, 1, 1, here also 0, 1, 1, the left hand side of the given identity produces 0, while right hand side produces 1. In the same way, for another input combination 1, 1, 0, left hand side produces 1, while right hand side produces 0. From this, we can say that the given identity is invalid. So option D is right. Thank you.